Good day, gentlemen. Today we're going to go over 4.2, right? It's using the laws of exponents. This isn't the entire list of laws of exponents, but just the ones that deal with multiplication because that's what we're really working with right now. Okay, so we're going to work with these three laws, okay? What do you do if you have, okay, a and b are going to be our constants for all this, and m and n are going to be our exponents, okay? So what if you have something like this where you have the same base variable, and you're multiplying, and you've got two different exponents? Well, all you do is you keep the same base variable, okay, and you add the exponents together, okay? One little separate part about this is if you have coefficients in front of that a, you have to multiply those coefficients together. So for this first example, 2x to the fourth times x cubed, okay, you really pretend there's a 1 there, right? So the first thing is we got to get our coefficients down. So you multiply 2 times 1, just 2. Okay, then you keep the same base. You have to have the same base. Right? It has to be the same variable there. If this was 2x to the fourth times y cubed, you wouldn't be able to do that. Okay, now x to the fourth plus x to the third is x to the seventh. Okay, so we add our exponents. You don't multiply them, you add them. So the answer to this would be 2x to the seventh. Second one here, if your power is acting on both, okay, you just distribute it to both. Okay, so a to the m times b to the m. So if you've got 4y cubed, this cubed has to act on both of these. Well, 4 cubed we know is 64, and y cubed we just leave like it is, just like that. And lastly, if you have a power to a power, okay, so we take this power and act it on this power. If that happens, then you multiply them together. Okay, so we got a to the mn power. All right, and last example here, we have to, first of all, distribute this. So 2 to the third is 8. Now, a to the 4 times 3, not 4 plus 3, because it's a power to the power. Okay, 4 times 3 is a to the 12th. All right, one thing you want to look over before you move on from here, make sure you see the difference between this one and this one. Okay, if you're multiplying the two things together, and they each have a power, you add them, add the powers, the exponents. If it's a power to a power, then you multiply the exponents together. Let's do some examples. Okay, so we have to simplify this. We've got c to the x times c to the 5 minus x. Okay, they've got the same base, right? And you're multiplying them together, so you're going to keep the same base. Now, what do you do with the exponents when you have the same base and you're multiplying? You add the exponents together. So it's x plus 5 minus x. Now, our x's just cancel out, right? X minus x is 0. So this is just going to end up at c to the fifth. Okay? Now, the 6y squared times the quantity of y squared plus y minus 2, we have to distribute this, just like we always would in any other class. Okay, we have to do each of them separately. So, 6y squared times y squared, okay, you're going to have the same base. Okay, so the 6 is going to stay, but your y squared times y squared, remember if you're multiplying two things with the same base, you keep the base and you add the exponents. 2 plus 2 is 4. That's a nice easy one. You can't really mess it up because it doesn't matter if you add or multiply, you're going to get the same thing. It's just a special case, obviously. Okay, the 6 carries over to the 6y squared times y. Okay, y squared times y, we have the same base, keep the y. 2 plus 1 is 3. And this last one, all we have to do is multiply our coefficients together, so it's 12y squared. That's it. Next one. Okay, we've got x squared to the fourth times x to the fifth. Okay, we got to do exponents first. You're still using PEMDAS. Okay, so we're going to do the power to the power first. Remember, if you have a power to power like that, you multiply them. So it's going to be x to the 8th times x to the 5th. Okay, now we just have one of these simple problems where you're just multiplying with the same base, so you just got to add the exponents, keep the base, so it'll be x to the 13th. That's the final answer to that. And down here at the bottom, x to the m to the n times x to the p. Okay, this one probably looks a little bit harder to you guys, But if you look at 3 and 4, they're the exact same problem. I just took out the numbers for exponents and put in variables. So it's the same exact process. Do the power to the power first. So m times n is just mn. You can't combine them. Times x to the p. Oops, that's got to be an x. X to the p. P power. It's supposed to be up. Yeah, okay. So from there, okay, now you've got to multiply. We've got the same base. Add the exponents. So it's going to be x to the mn plus p power. Okay? Guys, with variables, it's the same exact process. You're just not able to combine variables in the same way you're able to combine numbers. 2 more examples. Okay, a little bit more difficult ones here. Alright, so we got 2pq that we're going to distribute all into this quantity p squared minus 3pq plus 2q squared. Alright, so to distribute all the way through, and we will have 2pq times p squared. Well, the 2 and the q aren't going to be able to change very much, right? But we do have to combine the p and the p squared. So p times p squared is you just keep the base and add the exponents. 1 plus 2 is 3. Keep the q the way it is. So 2pq times p squared is 2p cubed times q. Right? That's a lot of stuff. Okay. The next one, we have to multiply our coefficients. So minus 6. P times p is p squared. You add the exponents. 1 plus 1. Q times q. Q squared. Add the exponents. Okay, and then lastly, plus 4, because we've got 2 times 2. The p is not going to change. Q times q squared is q cubed. And right there, we're finished. Okay, very last problem. A to the x minus 4 times the quantity a to the x plus 2 squared. So you have to do the power to the power first. Okay, do the exponents first always. So this part's not going to change. All right, but we're going to multiply it by, now the way you do this, power to power, remember you multiply. So a, distribute that 2 in there, and it will be 2x plus 4. Okay? Now, we've got the same bases. You're multiplying them together, so you add the exponents. So we have a to the x minus 4 plus 2x plus 4 power. Okay, the minus 4 plus 4 go away. We're left with x plus 2x, which is 3x. So our final answer is a to the 3x power. That's it. It's going to take a little practice, but you guys catch on.